So today we're going to learn about how to rearrange formulas. So typically you might have a formula. A formula has multiple variables. Sometimes it can have numbers in it. But the idea is the fact that I have too many variables here means I can't really solve it for a number. I have to solve it. I can only solve it for a letter. That is really just not clear at all, is it? All right. Well, anyway, let's proceed. So we want to get B by itself, just the same way we do with numbers. We're going to try and get rid of the letters. Oh, maybe that's a little better. Yay. Okay. It wants to be better. There we go. So how do we get B by itself? Already we currently have T by itself. I really want to get rid of CM. And what is the relationship between C and M? The fact that C is right next to M makes them multiplication. They're like a married couple. The only way you can get rid of a married couple is to divide away, divorce, right? We don't really want to separate the C and M though. All we want to do is get B by itself. So how can we get rid of C and M here? Subtract it, right? So subtract C and M from both sides. So I have T minus C M equals B. So I have gotten B by itself. So we're using the exact same process. We're only going to really be multiplying or dividing or adding or subtracting. Okay, for the next one, this is the circumference of a circle is pi times the diameter. Cherry pie's delicious. That's how you remember that. Cherry pie's delicious. How are we going to get D by itself? Divide by pi, because pi is just a number. It's an irrational number, but we're going to divide both sides. So C divided by pi equals the diameter. And since pi is approximately 3, it's 3.141592654, something like that. Okay, but it goes on for infinity, right? That's not where it ends. So essentially that means that if we were to look at a circle, our diameter goes around the outside of the circle approximately how many times? If we call this the diameter, it's going to stretch around. Here's a diameter. Here's another diameter. Here's another diameter. And then 0.14159 diameters, right? So here's a diameter, almost a little over 3 diameters. 14% of the diameter, approximately, right? So, does that make sense where we're getting, that formula, circumference equals pi times diameter, why I'm saying the diameter would fit around the circle a little over 3 times? If I bent it, it's a straight line, but if I curved it. Okay, and for this one, we have area equals 1/2 base times height. Now, I really liked the way that, Tina, you were saying this could be the same thing as base times height over 2. Does everybody see where she would get that and how that would be exactly the same thing? Because if I take 1/2 and I want to multiply by a fraction, BH is not a fraction. B times H, what's their denominator? 1. So if I multiply 1 times BH, I get BH. 2 times 1, I get 2. So essentially, when I multiply by 1/2, anytime I take half of something, I'm dividing it by 2. That's the same exact action, right? Now, what if I want to get B by itself? I want only B. So the opposite of multiplying B by H is to do what? Divide it. So if I put that in the denominator, the opposite of dividing by 2 is to multiply. And look at that. That's really we call that, if I talk about H over 2 versus 2 over H, those are reciprocals of each other, right? When it comes to fractions. Reciprocals. Okay, and so what happens when I multiply them together? If I have h times 2, that's not really how we write it, but 2 times h, what's anything divided by itself? 1. So I have to do the same thing to the opposite side. Since I multiplied by 2 and I divided by h, I get 2a over h equals, what's left on this side? These cancel, b. I could have done it in 2 steps, but I just kind of wanted to point out the idea of whenever we're multiplying by a fraction, we're multiplying by the numerator, we're dividing by the denominator. So if we do the opposite of that, that's the same thing as multiplying by the reciprocal, right? When we divide by a fraction, we multiply by its reciprocal. That's the rule for dividing fractions. So let's see about this one. Area equals, I want to write it so that it is a fraction here, pi r cubed times h over 3. Does everybody understand why that's the same exact thing? I want to get everything, I want to solve for h. So couldn't I just do the same thing that I did with the last problem? Do you feel confident about that? What would I multiply both sides by? Oops, pi r cubed, yes. And over here, I'm going to do the same thing. 3, because that was my denominator. I want to get rid of all this part, and that's all multiplied together. So pi r cubed. A is over 1. 3a over pi r cubed will give you the height of something. I don't know. That's probably area of something to do with something circular. A cone? Area of a cone? Okay. I don't have that one memorized clearly. Okay. Any questions about how we got that? You're seeing that reciprocal action, how we're able to get rid of everything and get h by itself? Okay, what about for the next one? We want to get y by itself. What are we going to do first? So we have, you're right. If I subtract c, though, I'm going to get them all onto the other side. And I really want to get y by itself. This is my goal, is to isolate y. So the first thing I can do is get rid of the ax, right? And then I'll be closer to having y by itself. How would I get rid of this ax? Subtract ax from both sides. Ax, by equals c minus ax. Or you could write negative ax plus c. That would be another way of saying it. Now, what is the action that's happening between, what's the relationship between b and y? Yes, they're married. They're multiplied, right? You cannot subtract away the b because just like, if you're married, you have to, if you don't want to be married anymore, you don't want to be multiplied, you have to divorce. Divide the b. So I'm going to divide both sides by b. b divided by b is 1, so there's y by itself. Now you could either write c over b minus ax over b, or you can divide them both at the same time. You notice that they have to have a common denominator, right? So it's the same thing. Y equals c minus ax over b is the same thing. I could have either one. Okay, let's actually just finish this one off right here, and then we'll be done with this. But we really do need to practice a lot more of these, don't we? So what are we going to do here? We want to get c by itself. Right, just same thing we did here, right? We're going to subtract the 32. So we have f minus 32 equals 9/5 c. Oh my gosh, we have a fraction. How can we get rid of, basically when we have a fraction, we're multiplying c by 9, we're dividing it by 5. Could we do one action to get rid of? Yes, we could, right? 5/9. And now we would have to do that to the whole other side. 5/9. That's why I put the parentheses in here. So 9/5 times 5/9 is 45/45, which is the same thing as 1. So these cross cancel, don't they? That was my point. 5/9 times f minus 32, because we have to multiply it by the whole other side, equals C. And a lot of you might be familiar with that formula. This is the formula for, instead, you could hear this one, Fahrenheit equals 9/5 C plus 32. That's how you would take Celsius and convert it to Fahrenheit. This formula will allow you to plug in the Fahrenheit and convert it to Celsius. You see the difference? So a lot of times it's very advantageous to be able to rearrange these formulas. Okay, any questions on that?